Good. Awesome. Excellent. Great to see you all. Thanks for coming to the very last 2023 Brighton Kotlin. Thank you. It's really cool. I say this every time, but it's really cool to see new people. And thank you for those who have traveled all the way from London to come down tonight. That's really cool. So just a few kind of housekeeping bits. You probably already know, but toilets that way. If there's a fire, that way. I was looking through the list of talks that we've had throughout the course of this year, and it's been a really cool kind of year for kind of Kotlin meetups generally, I think. We've had some really, really cool talks. All of those talks have been supported by cool places like we're in now, Runway East, and the other venues that we've used throughout the year. They kind of give up their kind of venues for free and allow us to use. All of the talks throughout the year that we've done have been supported by Silicon Brighton. Silicon Brighton support like an absolute ton of tech meetups on the South Coast. They are what make these kind of meetups for people like me who kind of run these. They're just easy. As you can see, they bring an absolute ton of tech with them. It just makes the streaming online and the in-person events really, really easy. Do you want to do a quick intro to Silicon Brighton while we're here?
Hello, everyone. Thank you so much for being here. I really appreciate everyone coming along to these events. And this is an absolutely fantastic speaker that we've got this evening. So really fab. I want to just say a quick thank you to the production. So thank you to Cam. Thank you to Tabo. Thank you for our volunteers. We've got some Silicon Brighton volunteers with us this evening. We've got Ben and we've got Mo. So put your hands up, Ben and Mo. If you need anything throughout the course of the evening and you can't find me or you can't find Lee, then by all means, ask Ben and Mo, because they're absolutely legendary. And there's more for me to say about Silicon Brighton, but mostly I just want to say thank you to you all for being here and really blah, blah, blah. That's all I have to say. Thank you very much. Bye.
Awesome. Thank you. So this is the last one of the year, and we definitely saved a really good talk for the last event. Thank you for Andre for coming down from London and preparing this talk from us. I don't think it gets much better than having a talk from one of the creators of the language of the last one of the year. So I won't waffle on much longer, just to say that we've got a couple of JetBrains licenses to give away. So I'll reach out after the event for one person who's here in real life and one from online and kind of reach out to give you your license. I think that's it. Over to you.
Thank you. Hello. Thanks a lot for the introduction. Thanks for organizing this and inviting me. I'm very happy to be here. So today I'm going to talk about how Kotlin came to be and why this crazy thing happened at all. I very welcome your questions at any time. So we're a small crowd here. We can have a chat. That's all right. So I don't have to finish all my slides. If we end up talking about something else, that's great. All right, so a few things to get out of the way. I do not represent JetBrains anymore. I don't work there. Haven't been for 3 years now. Just close to the anniversary, really. Like it was exactly in November 2020 that I left. So everything I say is a lie. I may misremember things and all that. So if you're quoting this anywhere, just quote me, not the company. So a little bit of context about me. So Kotlin was a big part of my professional life. It was 10 years from 2010 to 2020 that I led the project and did the language design, parts of the compiler, all the team management and everything. That was an incredible journey. So before that, I did some teaching and computer science research and stuff like that. A little bit of an overlap. I co-founded a company that does mental health, nothing to do with programming. We'll write some code, but it's not very sophisticated code. We don't even write Kotlin there. It's written Python because it's cheaper to hire Python developers. So that is something ongoing. Congratulations, you people. If you actually write Kotlin, you make more money than the Python people. So what I mostly do now is working at this company. I do some mentorship coaching for tech leaders because like this thing taught me a lot. And I try to help other people who are in this similar situation. Yeah, so I'm a little bit pulling away from the language engineering side, but I still remember a lot of things, so I'm happy to share. Yeah, so here today, I would like to more or less reflect on my own experience working on this project, share some hopefully entertaining stories, also learn more about what's interesting to people about this story. So all your questions, I'll try to remember. I'll watch the recording and try to fix my slides to have more answers to such questions in the future. Okay, any questions at this point? All right. So this is something every sensible person tells every other person when it comes up in terms of like whether you should create a language, you shouldn't. And this is what I'm telling you, you shouldn't create new languages. It's a bad idea most of the time. But here we are. So what happened there? I'll try to open with kind of a story. Okay, sorry, I'll just do this because it's very much in my way. Okay, so my first encounter with JetBrains as a prospective employer was back in 2010, and a friend of mine who worked there invited me over to talk about something programming languagey, and I thought it wasn't anything about a general purpose language like this. So I didn't think the conversation was about anything like Kotlin. I thought it was about domain-specific languages because I was doing a PhD in domain-specific languages, and JetBrains also had a very famous project in that area, so I thought they wanted to, collaborate or do something about that. And I was very much surprised when they told me they wanted to create a new language. I was like, guys, you're crazy or what? Like, you're software professionals, you know you shouldn't do that. And like my basic arguments were, first, never make new languages. Second, there's already Scala. 2010, Scala was more or less cutting edge of the JVM ecosystem. So why on earth would you do that? It was a long conversation. I came in, I think around like 6 p.m. and I was catching the last subway train on my way back. So it was around midnight. And yeah, so I went from here to, okay, it's a good idea actually, because a lot of reasons why Scala doesn't cut it for the industry, because JetBrains is a very good position to actually make a language popular, and and a lot of other things. And we actually sketched initial bits of the language design on the whiteboard that same evening. So it was kind of a very quick switch of gears for me. It was pretty exciting. And also, I didn't start the next day because I was doing something else in a different country at that time. So it took me a while to actually catch up with the team and all that. But here is where it all started. So what arguments actually worked for me and for people at JetBrains to start working on such a crazy project? It was back in 2010, and it was a very special moment in the industry because it was like 10 years after the dot-com crash, and the aftermath of the dot-com crash was like pretty hard on a lot of companies, including some microsystems that created Java. And basically it killed Sun Microsystems closer to the end of the 2000s, and it was acquired by Oracle. And in this whole jam, Java was neglected for a long time. So by that moment, the last meaningful version of Java was Java 5 that came out in 2004. So by that time, it was 6 years of no meaningful updates to the language. Like, everybody was pretty pissed about that, because alongside Java, there was C# that was advancing very, very rapidly. And it was very obvious that the quality of life of C# programmers was much, much better than Java programmers. So there was this like very clear understanding in the industry that Java is sort of falling behind, that's a legacy language, and nobody knew if it would actually catch up ever. It did, which I'm very happy about, but like wasn't clear at the time. And basically it took Java 10 years to put out the next really important language update. So Java 7 did add a little bit to the language. but the real thing was Java 8. And, 10 years for a major, very needed update is a long time. So a lot of people were pessimistic about that. So this basically created a window of opportunity for people like us to put out a modern language for the Java ecosystem, because despite all this, there was a ton of Java programmers in the world. There was a lot of code running. There's a lot of people writing this code. And it was very clear that Java is not legacy in terms of how many users it has. So there was a niche, like people on this platform really wanted a good language. And Java was a very good language back in 1995. Yeah, so any questions about this? All right. Yeah, so basically, everything I said, there were alternatives to Java on the JVM. There was Groovy, there was Scala, and obviously they didn't get enough traction in the industry. They were pretty popular for what they are, but they couldn't replace or provide enough competition to Java for obvious reasons. So Groovy is that dynamic language. Dynamic languages scale to a certain size, and just you can't really economically write a big project in a dynamic language. And Scala was basically too academic, had too many very smart features that very few people could use, and so on and so forth. Also, Scala didn't care about binary compatibility and other things that really concerns engineers in the field. And people would do weird things. Basically, every version of the Scala compiler back in the day was binary incompatible with the previous one, which meant if you want to do a minor update in your code base, you needed to wait for all the libraries you were using to recompile. Then you can take the versions of those libraries compiled with the right compiler and recompile your code with the right compiler. So, it's pretty painful for a lot of people. And also, if you have a big team, you have to do it all at once. You can't take the binaries from your build server before you updated your compiler. So, it was Scala was a tough story for a lot of people. And then there were more fundamental things this kind of thing you can fix. There were other things about the language that didn't really work out. So, yeah, this is how we went. And back in 2010, JetBrains wasn't a big company. It was about 300 people. It had a lot of products for different languages, IDEs for major ones for Java and C#, and a lot of other languages were supported as well. There was a fairly popular build server called TeamCity, not very popular issue tracker called utrack. And this is the DSL research project that I initially thought we'll be talking about. So it wasn't like a giant company like Microsoft or Apple or the likes of those who usually put out languages, right? So the normal success recipe for a language is you make a platform like Unix or Java or the browser, and you attach a language to that platform. And if the platform is successful, the language is successful. It doesn't matter how bad it is. Not pointing any fingers at JavaScript. So, this is the recipe. Otherwise, you are going to have a very tough day. Have a tough day for a while. So, but for us, there was no platform we could put out. Nobody needed a platform. And also, there was no platform in sight that could pick us up. We didn't know that Android would be big. It could be a decent guess at the time, but we didn't realize that. So, it's we ended up a default language on a big platform, but we didn't plan for that. We planned to just plain compete with Java on its turf, which was a bold move, but, even before Android worked out, Kotlin kind of picked up. Any questions about this? All right, you can actually ask questions. I'm not doing this routine just for a pause. All right, so that was JetBrains. Now me, back in 2010, I was 26. I was working my PhD. The worst possible way you can work on a PhD without a relevant advisor, without a group to work with, it was a complete mess. And I dropped out eventually out of that PhD program. So, when I was doing a lot of teaching, I taught at high school, at colleges, and other places. And, it was all sort of, I wasn't even sure whether I was a good programmer by that moment, because like I knew I was good enough when I graduated a couple of years before. But I wasn't super confident because I was teaching all the time and didn't write a lot of code. So the same year, I went and had an interview with Google just to make sure I'm still good enough. And I was. And like I get regular emails from Google since then, fairly regularly, which they do to everybody who just passes the interview process. Yeah, so I was this like very young person with very high levels of self-confidence and some academic experience, but like very little industrial experience. I worked as a developer at Borland back in 2005 and 2006. So, and yeah, this is how it started. So I finished my academic engagements, finished one visiting position, another internship, and came back to create my own language. So, and it was a lot of interesting things, but here I have a list of things people usually ask. So I'll just go through this like list of basic questions, and hopefully we'll hear something funny. So yeah, the timeline for Kotlin is we started 2010, and at that moment the language did have a name. It was Jet, because JetBrains wanted its brand advanced. And I think somewhere around here we had a huge disappointment. We checked the trademark and it was taken. It was actually it was a big sort of annoyance for me, because even I realized how hard it is to pick a name for a language. So somewhere around here, because we had to make an announcement, we had to settle on a name, and we were agonizing over a name, because what you need is basically something that's Googleable, that's also recognizable by ear, doesn't mean anything bad in any language, and also like is more or less looks coherent. It was very tough. Like we had a list of, I don't remember how many candidates, maybe like 20 or something. And no, you cannot pick a name that is not a bad word in any language. So Kot means dog shit in German. And like, this is the best you can get. Like it will mean something disgusting in some language. And I think it also means something disgusting in Mandarin or something similar means something disgusting in Mandarin. So it was like, we weren't really sure about it, but we had a deadline. When the deadline hit, we just agreed that it will be a code name. Like we're not committing to it, because so this is why we announced it as Project Kotlin, because it was a code name. But then, of course, like nothing is more permanent than temporary. So, it just stuck and kind of worked. So the name comes from this place. So St. Petersburg is where I'm from and where the office of JetBrains was. And Kotlin's this island. It's like not very spectacular in any way. Like there's a military base there and a huge cathedral, and that's it. There's nothing else. But there was this sort of trend of naming languages after islands, because Java is not only coffee but also an island. And there was a Ceylon language, which is like the opposition. Java is the island of coffee, and Ceylon is the island of tea. Kotlin is the island of, I don't know, battleships. But still, like we went with it because it was like, it's a very Googleable name. I mean, very few things in the world are called Kotlin, but not only programming languages nowadays and islands. So yeah, this is the panorama of the island. And here is something called Kotlin. It's a Soviet destroyer that has a different designation in the Soviet nomenclature, but Americans, for some reason, call it Kotlin class destroyer. And my early presentations have this disclaimer that the language is not meant for class destruction by any means. We didn't really destroy many classes. But also, this is, I think, a British ship of class Haskell. And by the way, 239 is the number of the high school I worked in and went to, which is a coincidence. And also, this is Scala, Renault Scala. And by comparison, you can see which one's better. Yeah, so I also already mentioned that German doesn't like Kotlin, but also Kotlin is a thing not only in Germany. Kotlin is a thing in Poland. This is real. It's a brand of ketchup. It's some small town in Poland that gave its name to this ketchup. And some people, like once in a while, we got souvenirs of like real bottles of this ketchup in the office. It's okay. I mean, not a bad ketchup. Yeah, so the naming thing is like always a lot of weird things popping up. Yeah, but overall, it turns out to be a decent name. Any questions about the name? Go ahead.
You described it as coherent.
Uh-huh.
Do you think that you can like see it and know how to pronounce it?
More or less, yeah. Yeah, so I think people, like, there are languages that have trouble transcribing this, but like most people can spell it more or less if they have seen it at least once.
Was it your idea?
No, it wasn't my idea. So it's interesting how a lot of things about Kotlin, like a lot of super high level conceptual things, like we want a new language, here's the name, and I think something else, is done by the same person who's not like, he worked on the project with us, but like he wasn't really in charge of the language. His name is Dmitry Jemerov. He actually wrote a blog post, like the first blog post in Kotlin, like why JetBrains needs Kotlin. He did that. So it was his idea to have a language. He did have some like small input into language design, and he came up with a name, and he led the IDE team for the language for a long time. So yeah, it's a big contribution. He didn't know about the ketchup. That's unintentional on his part.
Other than Jet, do you remember any of the names you rejected?
Oh yeah, there were quite a few. Like I definitely remember we played with the name up and some like derivatives of that, because like a 2-letter word is a good thing for, file extensions and other things. But I think it was around the time when Go came out. I was very clear there's a very bad idea to have some name like this for like reasons of working with Google and Wikipedia and everything else is going to be bad. Were there some other, like, it was a very long list. I don't remember other options, but they were pretty bad, all of them. I mean, this one was bad as well, but we just had to settle on something. More questions? No? Okay. All right. Another question I get very often is like, why would JetBrains do something like this? Because the language itself is open source, right? So there's no direct revenue stream off this language. And yeah, that's a fair point. In general, you don't make money off languages at all. Like, I think, yeah, nowadays, maybe nobody at all charges anything for new languages. There are people who charge money for compilers for old languages, like a COBOL compiler will be an expensive piece of software today. But generally, no, you don't sell languages for money. And this is the thing of the 90s, maybe early 2000s. But JetBrains had a very direct interest, other than that just frankly being cool. There were other like fairly rational considerations. So basically what happened there was back in 2009, 2010, folks, JetBrains had this like big assortment of different products for programmers, which were mostly IDEs for different languages. There was the sense that, okay, so we know how to make developers' lives better through an IDE. We know how to make an IDE helpful, how to make it like performant enough, popular, so on and so forth. So what else can we do for developers? And so yeah, Dmitry's idea was to maybe we should stop following trends, because like the way it worked, there was a programming language out there, it picked up enough audience, and we realized it's now a big market for another IDE, so we put out an IDE. So now we can set a trend. We can say, okay, here's a language. If you guys like it, it already comes with good tooling. And it automatically, of course, creates a market for another product from JetBrains. Turned out to actually be an existing product, so we didn't put out a special Kotlin IDE, but still, it's quite a bit of a market for a JetBrains product. So, it's pretty clear that having a private market is a good thing. Another thing is obviously brand awareness. Like, people like to argue about programming languages probably the most of all technical topics. So it's definitely a brand that will be all over the internet. There will be haters, there will be lovers, and the name of the company will be much more visible than was before. And that's true. Like, we can see from marketing research, from all sorts of data, that the brand of JetBrains is much better. Even though a lot of people still think that Kotlin is a product of Google, for obvious reasons, there is like the matter of weight works in the branding area as well. But still, like, it helps the brand of JetBrains quite a bit. And actually, I think every story told from inside JetBrains and from JetBrains to the outside actually started with this last point, which was, we first of all want a good language for ourselves because we have a huge Java code base and we're fed up with Java. We want a language for ourselves because this is the culture of JetBrains. So the way the philosophy behind everything JetBrains does to this day is, we are a team of good engineers. We know how to make ourselves productive with tools, and whatever tools work well for us will work well for the industry. All right. Yeah, so this dogfooding heavy culture, I think I have my slides out of order. Yeah, so this dogfooding mindset was very important for JetBrains. And the overall, the approach to product management within the company is, if it works well for us, it will work well for all of other developers. And this basically is how it is with IDEs. Good IDEs are made by developers who are using them. And this is why everybody's on the bleeding edge version of the IDE inside the company. And also this approach to customer support where, if you have an issue with a JetBrains product, to this day, you're put through to a developer very quickly. You don't go through a lot of lines of support, because this is how you make products well. If you want them to work well, you have developers talking to developers, and this is the best way to understand what users need. Yeah, so what I had on the previous slide is that JetBrains is actually a fairly non-standard, non-conventional team, because it has better than average engineers. Very few people leave the company. Also, it has this dogfooding culture, which is not typical for the industry. They're a horizontal organization without much management and all that. Almost everyone writes code. Even people even the CEO of the company still writes code, because he just can't survive without writing code personally. And there is also this huge emphasis on autonomy for individual engineers, which is not typical for the industry. So this idea that whatever works for us works for everybody else has limitations. But fortunately, for things like IDEs and programming languages, it works pretty well. So it does carry over for some tools. Any questions about this? No questions. All right. So this is how we approach this. And yeah, so by contrast, the industry back in the day, the JVM industry was mostly enterprise developers doing server-side or maybe a little bit GUIT. And it was very different from the actual people in JetBrains, but it kind of worked. Yeah, and as I mentioned, we did not plan for Android. It was not on the map at all. So there was this was the Android moment. So basically, somewhere soon after the announcement, but before we open sourced, there was a first mention of Android in our vicinity. So before this time, nobody really thought about it. And sort of in the hindsight and retrospect, it sort of makes a lot of sense that we should have targeted Android from the beginning. Because it's pretty clear that, like back in 2010, it was pretty clear that smartphones were a big thing already. And that if Google wants to put out a competitor to iPhone, it's probably going to be big, although, big companies failed at that, but still. And this was not as clear back in the day, but still, like why it worked is because Android was even more stuck in the past of the JVM than Java proper, because it has a different virtual machine, and the virtual machine is on every device, and updating virtual machine is a problem. So you're basically stuck with an old bytecode format, much longer than even the server-side users that have conservative update policy. So Android was at Java 6, even when Java 8 was already out. And the developers in this ecosystem were like very unhappy about that. And if you're working in mobile, you know that this updates for the virtual machine and devices are still not very easy, and all that still has a lot of a long tail effect. But also, you probably heard about the Oracle lawsuit against Google over Java. This also is a huge problem with this Java bad idea inside the organization. And when we worked with the Android division, there were a lot of issues over this litigation going on, like limitations in the processes and so on and so forth. There were very scary moments when we almost did something bad, by unintentionally, absolutely, of course, but because we were moving code around and other things happened. So no, it was a lot of tension around Java inside the organization. But also, from the user side, it was very obvious that Apple was moving forward with Swift. Swift is a good language. It's very clear that it's the kind of leap that was needed both on the Android and the iOS side, and the iOS side did a pretty good job. So everybody really wanted something better. And while Google is successful with some languages, Go was a very big hit. Dart didn't work out that well, and it was never meant for mobile development in the first place. But still, it wasn't clear if Google can actually create another good language from scratch. So people were kind of dubious about that. Flutter was a huge hit among UI developers, but Flutter is in Dart and done by another organization inside Google, not the Android organization. And there is a lot of internal politics around that, but also it's very difficult to switch existing Android devices to Flutter. So, it was kind of a huge mess of different factors that sort of converged on, okay, so Dart is not the next language for Android. Go is not the next language for Android. We need a next language. What can we do? For context, Google was using IntelliJ IDEA Community Edition, the open source version of IntelliJ IDEA, as a basis for Android Studio for a long time. So there was an established relationship between Google and JetBrains, which probably helps quite a bit to persuade the decision makers within Google. But we didn't really take any part in that. So we really wanted, since we released Kotlin 1.0, we really wanted Google to adopt it for Android, or at least endorse it for Android. But all our efforts went in vain. Nothing happened. What actually happened was that the developer community, the Android community, which people over at Google do listen to pretty carefully, they have this kind of regular community survey. It's not like a popular survey. They have a select group of experts that they talk to regularly. And in 2016, 2017, this group of experts named the platform issue number 1, we need a new language. And this is how this whole thing happened. So it was basically it was picked up by people at Google, but it was requested by the community, and the push came from the developers. Yeah, so this is an interesting bit. So this is a screenshot from a US database of trademarks, which says an interesting thing. This is a historical record. It's not like this anymore. But it says that, it says, say Kotlin anywhere. No. Okay, so it's actually from a Kotlin record. It says that the trademark Kotlin belonged to Google at some point. And it did. Because the way it happened was, like, we didn't expect anything. Like, we kind of tried quite a few times and we realized it doesn't work out. Okay, so we were just keeping Kotlin compatible with Android as much as we could, and developers were picking it up. Some people were using it in production. We were very happy about that. And then at some point, we get a call from colleagues at Google, and they want to talk, and we set up a video call, and they say, okay, so we really want to make Kotlin officially supported in Android in 3 months from now, because we have this Google I/O conference and we want to announce it. We're like, great news, what do we do? And this is where it got really complicated, because if you think about it, so Google is a huge company, JetBrains is a small company, and Google is already being sued for a lot of money over language. So there's no way we just shake hands and they commit to Kotlin, right? So of course, the first item of business was, can we just buy JetBrains, please? And it's a long-standing decision of the founders of JetBrains. This company is not for sale. So that was out of the question. And then it was like a fairly complicated arrangement where like Google has to make sure that even if somebody goes crazy in JetBrains, or the owners of the company want to sell the company at some point to somebody, like to Oracle, for example, or something else happens, Google has no huge risk in that. And we sort of, it was a negotiation process. I was on the side of like how the trademark will be managed jointly. So the only thing about Kotlin that matters is really a trademark, because all the code is under Apache 2 license. You know, it's a free license. Anybody can use it, but the trademark is something tied to an entity. And so the whole thing was mostly around who manages the trademark. So we decided we'll be setting up a joint entity that will manage the trademark, which is fine, but you cannot set up a joint entity in 3 months, especially if there is like corporate lawyers involved in both sides. So we had to figure out something we can do very quickly so that Google is not running a huge risk. And that arrangement was that JetBrains makes an agreement with Google that we had a trademark over for a while. As soon as we set up an entity, Google transfers the trademark to the entity. But meanwhile, it belongs to Google, so they have no risks there. And of course, like JetBrains was running some risks, not as high as Google because we're not as big a company. But you know, it was a fairly like nerve-wracking process of deciding on this. And yeah, and a year after there was the Kotlin Foundation set up, and the trademark is now there, and it's jointly managed and all that. But yeah, so this is like a piece of history that signifies how much, you know, it wasn't like tense negotiations, but there was a lot of tense internal discussions of like, what if everything falls apart over this? Yeah, but everybody was nice, and it all worked out very well. But the memory's there. Any questions about this? No questions. Okay. Yeah, so as soon as this was done, we could do, like Google could do this announcement, which is very big, and we were we're incredibly tired by this moment. Where's the music coming from? All right. Yeah, so we were incredibly tired by this moment, but it was very nice to have a celebration. So that was a big and sort of important moment. After that, our user numbers picked up quite a bit. So this is already 2017. So this 1 million users were made with the Google announcement. Before that was like nearing 100,000, I think. No? No luck? Okay. Yeah, so, and since then, it was growing pretty fast. I think by now we are not very far past 5.8 million because it's basically the number of mobile plus server-side developers possibly interested in Kotlin already. So we kind of hit the cap of the market, but still it was pretty rapid growth. Any questions about this? All right, and now to a little bit more technical detail. So we did not plan for Android at all. And this is why something like this happened. So back in 2012, somebody asked in our forum, like, does Kotlin work in Android? And I was like, I don't know. Maybe it should technically like try. And they tried, and there was some problem, some error code from Android. And I was even pointing to it. It's actually a wrong issue. Like, I mean, a wrong Stack Overflow post doesn't solve their problem. But I had no idea what Android was. I mean, how it worked. So yeah, somebody dug in and looked up this error message. And the unpleasant thing is this. So basically, what this means is that our code didn't even hit the device. It failed at some point during translation from Java bytecodes to Dalvik bytecodes and DEX. And so I really hated this because if you have a segmentation fault in some kind of native application, what it means, I have a pile of C or C++ that I have to debug myself to figure out what it is. I didn't really want to do that. Well, fortunately, this error message is sort of informative, and you could see what this means. And we figured out that we were putting a wrong flag on a class file. Turns out, an interesting thing about Android is that the people who did the Dalvik virtual machine actually read the spec for the JVM, which the people who did the hotspot machine didn't have to do because it was spec'd and coded at the same time and the spec wasn't around. And that's why the hotspot implementation is super chill about unimportant details. And it doesn't care if you put a wrong flag on a class because it doesn't change anything. Like this flag doesn't have a meaning on a class. So hotspot doesn't care, it works. But Android properly rejects this class file and segfaults, which is a strange detail, but this is how it works. And yeah, so we realized we were putting a wrong flag there. And there was a chain of such problems later. Like, for example, there's another flag, which is legacy. It's called ACC super. It has to do with how some sort of methods, like super methods, are called in classes and the JVM bytecode. And the proper JVMs, they don't care about this flag. They ignore it because it was something about Java 1.0 point something or something like that. But Android people actually read the spec and implemented this behavior, which is completely weird. Like it's something, the mistake in the early version of Java. And if you put this flag, or if you don't put this flag in a class, just get some weird behavior, like your supercalls don't work or something. So yeah, we had to find it out. Like our users reported a problem to us. Like, okay, we're running this code in Android and something just clearly doesn't work. Yeah, and later we just started using Android bytecode verifier to make sure our bytecode adheres to the spec, because it was more picky about the spec than the stock Java one. It was quite an interesting discovery. We actually have a piece of Android toolchain running within our test suite. Like anything that would generate in tests goes through the Android bytecode verifier. Yeah, so it was like a discovery path through this world of Android that's sort of nominally the same as the JVM, but it isn't. Any questions about this? Go ahead.
How long did it take between February the 12th and until you were able to actually run it on Android then? Yeah.
So it was actually, I think this bug was fixed very quickly. And I mean, it's a flag, you can just remove it. So some code, I think, run the same week or next week or something. But then there were more and more issues discovered. Like this ACC super thing was, I think, still in 2012, but later. And then there were some other issues. And sometimes, like this is the ACC super problem. Sometimes we'd like looked at this and it would require us a lot of research. But fortunately, some other languages already had this problem and had it fixed. So we're like looking over their shoulder in their issue tracker and their code bases. And like this one got fixed very quickly because like Groovy people actually looked into it already, and we knew how to like what the problem was, because like it's completely unobvious what's wrong with the some kind of flag behavior. So open source is great. You can learn from other people.
Can I just ask? Do you think that you said that JetBrains didn't plan for Android? Obviously, that was massively good for the language. It kind of boosted numbers. But what do you think JetBrains would have done first if it wasn't mobile? Because I still talk to people now who, when you say you're a Kotlin developer, they just assume you're an Android developer.
Yeah.
Rather than the whole ecosystem that's available.
Yeah. So the initial idea was targeting the then majority audience of the JVM, which was server-side developers. So basically, this is another difference between JetBrains and the rest of the industry, because JetBrains is probably running the biggest desktop application written in Java in the world, as well, especially given Eclipse's demise. So, it's like very few people in this world do desktop applications in Java. Most people do server-side, of course. And this is what we were targeting. The idea was all the enterprise developers, all the web developers, everybody who's using Java on the server side would be benefiting from Kotlin. That was the target. And it just so happened that it's also good on mobile and other applications. More questions? Okay. Yeah, so just for good measure, our interesting adventures with the JVM weren't confined to Android. Like we broke not only the Android toolchain, we also broke the JVM itself. This is an interesting example. So here is, it's also some old syntax when we had namespaces instead of packages in Kotlin, for example. Yeah, so what we had back then, it's just a test, right? So we are creating an array and we want to set an element, not through an equal sign, but through an actual set method. And there was a bug in our compiler that instead of calling a proper JVM instruction for that, was just trying to call a method called set on an array, which doesn't exist. When a method doesn't exist, there is a special exception in the JVM. But if we're talking about a method that doesn't exist on an array, this is what you get. It's not a segmentation fault from the JVM, which is kind of a little bit of a security problem on the JVM. Basically, no idiot before us ever called a set method on an array, because arrays are special, you don't call methods on them. And apparently the array class in the JVM is so optimized, it doesn't have a virtual method table. And like, if you want to look something up in that table, just seg false. It's already fixed already. It was like from Java 6 or something. Yeah, but we made a few discoveries like this. Like when you just write a compiler and you have bugs, you emit code that may just not run or may crash the JVM, and you'll have an interesting case on your hands. We also like found out a lot about like internal optimizations of the JVM. For example, like to make your loops run fast, you have to emit them in a very specific way, because there is a very specific optimization in the JIT compiler that doesn't work if your code is structured a little bit differently. So it's semantically the same, but will be very slow. And like there were quite a bit of things like this. Any questions? No questions. All right. Interesting. I wonder if am I not making any sense? Okay. All right. So yeah, through this kind of discovery, through bug reports and everything, Android became one of our priorities by 2014. We realized it was a good user base. there was also like my idea behind making it a priority was that Android obviously had a growing ecosystem with a lot of new projects. It's much easier to start with a new language from scratch than to introduce it to an existing project. So the idea was we'll try to target this crowd and they will have less trouble picking up a new language. I don't know how much this bet worked out, but in the end, it all kind of came together. Okay, so yeah, our result was basically we were aiming for these requirements. We wanted an interoperable language with good tooling that will compile fast, be learnable, stable, won't like fall apart between versions, readable and safe. And we called it pragmatic language for industry, where like industry is big projects, big teams for a long time. Pragmatic being basically we're not doing academic research here. We're not like Scala. You don't have to be afraid of us. And a lot of this worked out, not everything. So our tooling for Kotlin is still not as good as for Java, because apparently if you write an IDE for 20 years, it's a pretty good IDE. It's not easy to replicate for another language. Like, it's still in the works. We managed to run very fast, but our compilation speeds, aren't as great. And I'm one of the people to blame for that, because like my initial approach to writing this compiler was, let's write a prototype and we will like redo it from scratch properly later. And it never happens, right? And it didn't happen. And this like the redoing it from scratch is only happening now. Like Kotlin 2.0 or like whatever is like K2 compiler is the rewritten compiler that was planned back in 2010, basically. So, lesson learned there. Yeah, so basically in 10 years, we got like 5 million users on different platforms with different application domains. A lot of universities teach Kotlin. It was a pretty successful project overall. And yeah, so biggest lessons I learned there. Yeah, so prototypes do get released all the time. Like never, ever try to show any users any prototypes. They get released. Another thing is you get what you measure. So one thing we didn't pay enough attention to was performance of the compiler itself. So we paid attention to a lot of things, like how safe the language was, how well it conformed to the spec, how stable we could keep it over time, so on and so forth. We paid attention to all that, but didn't have performance benchmarks from the start. And this is one of the reasons why the compiler is slow. Never again. So if I were doing this all over again, I'd have performance benchmarks from the very beginning. Like my initial parser code would have performance benchmark next to it. Also, we actually took a very long time developing the first version. So Kotlin 1.0 came out in February 2016, which is almost 6 years later than we started, which is not a good idea. Like working on something for 6 years is a huge risk in very many respects, like motivation, of course, but also the market changes. And we actually missed Java 8. So Java 8 came out before Kotlin, which was a marketing problem, like was a hit in our possible relevance. So what I think should have done is just release something not finished, like not final design, that we would break earlier, and just be upfront about it. This is what worked very well for Swift, which, Swift is not a great benchmark because Apple actually owns the market. So whatever Apple says, everybody will do. But it actually worked pretty well. So they put out a 1.0, and they then broke compatibility like 4 or 5 times in major releases later. And when we had the initial 1,000 users, 10,000 users, I think it was possible. Like we could do this and have a much more much fewer things in flux over time, and therefore much more stable following and much more clear messaging to the community. Again, lesson learned. And also, if anybody ever offers you to develop a complex, a very complex system, interfacing with another very complex system, and very compatible with it, ask for a lot of money. because it's the biggest headache of all time to keep two languages talking to each other in a way that like nothing breaks, everything's smooth, everything's fast, everything type checks, and everything connects at runtime, and everything sort of just works together while both are moving forward. Java is developing, Kotlin is developing, and we have to keep this property around. Like backwards compatibility within one language is a challenge. And we made some progress there in terms of like advanced the state of the art a little bit. But like interoperability within another language that's moving, it's a whole other story. Yeah, so a very big lesson. Like it felt, I think in the beginning, it was pretty clear that you can make a language very compatible with Java. There are challenges, but you can do it. And we didn't put much thought into this, like, okay, there will be next version of Java. And are we sure it's going to keep all the compatibility things? Most things worked out, but like there were big roadblocks. Any questions about this?
So in terms of the compatibility, then presumably you just have a huge number of test suites. Is that how you maintain it?
It has a lot of test suites. It has a lot of projects. So basically, the way we do testing for Kotlin is we have like small tests. We don't really have many unit tests, but we have like functional tests on small code examples. We have like bigger test suites and like really like proper production size test suites. Just we took some open source projects and keep compiling them to make sure that everything works. And the Kotlin compiler itself was, of course, started in Java and has a lot of Java code. So we used that to make sure that we keep all the interoperability working. Yeah, so it's a lot of tests. Like it's not only around the interop part, it's around everything. Like I have a lot of tests.
Thank you.
Yeah.
Did the change to the kind of Java release cycle and schedule impact things at all? Or did that make it a lot harder, or did it not really matter?
Well, in terms of keeping up with compatibility, it turns out the release cadence of Java doesn't really change much because, first of all, a very good thing about the Java team, they are planning ahead for a very long time, and they are very transparent in terms of what they're going to do. So it's not like the problem is not that they release their versions too often, and like it's much bigger problem for the larger Java community that new versions of Java come out than it is for us, because like we'll probably adapt in maybe like a month or two, but the community will keep picking it up for a very long time. And this is why there are like bigger cycles within the cycle. Like why like long-term support releases are not coming out every half a year. So this is not a big challenge. The very fact that Java is moving now was scary in the beginning. Like it wasn't super clear whether it renders Kotlin obsolete. Now it's fairly clear that it doesn't, for various reasons. So one thing is, of course, there's still Android that can't really keep up with the Java virtual machine evolution. The language evolution is fine, but the virtual machine is very difficult. So that probably stays around. But also what we see with the Kotlin users on the server side is like Java is adding very good things, and we're trying to pick up as many of them as we can to keep compatibility and keep good ideas flowing. But generally, Java is not trying to close the gap with Kotlin. It's trying to close the gap with a better Java, which is a great thing to do. And it's kind of not really turning many people over from Kotlin back to Java. Some people have a tougher time making a decision between Kotlin and Java from scratch, maybe, but we don't see many users just abandoning Kotlin, going back to Java. Very few. More questions? Yeah, another one.
What do you think will happen to Kotlin with respect to the project Loom?
Oh, it's a good question. So I don't know what's happening right now, so my information will be like 2 years outdated. But basically, Project Loom is a very interesting approach to making the Java platform sort of asynchronous, which, I mean, it has its trade-offs. It's not very fast, but it's the best way to do it on the Java platform. So I guess the bigger question here would be what happens with the Java world with Project Loom. And we probably already know more than I do myself. So probably something has already happened, or maybe it hasn't. I don't know. So Loom is done by very good people. I think it will get a lot of adoption. So Kotlin coroutine's story is fortunate. Well, it's fairly deliberately very compatible with Loom and other things like that. So Kotlin coroutines, it's a different approach to asynchronous programming, and actually more popular approach. So the coroutine-like things were introduced to the mainstream through C#. Async await was a great breakthrough for the entire industry. And this is called stackless coroutines, where you have, basically you don't have to talk to the virtual machine much to make coroutines work, because you can just turn a bunch of code into state machines and it just works. With things like Loom or Go routines in Go, you have a much deeper integration between the language and the virtual machine and can manipulate the call stack. And this is a big deal. Like, it's much more transparent. You don't have to mark your asynchronous code. You don't have the red-blue code problem where you're either within some asynchronous code or not. And it depends, like, what depends on this is whether you can make asynchronous calls from this particular piece of code. Because in C#, only a async function can make an await call. In Kotlin, only a coroutine, like suspend function, can make a suspended call. So this is a problem Loom doesn't have. There's a problem coroutines don't have. But there is, in the case of Loom, there is a little bit of performance penalty for this kind of thing. So I think both will coincide, and Loom can be a runtime for Kotlin coroutines, but I think Kotlin coroutines have applications outside of Loom runtime. We'll see. Well, probably a lot of people already know what happened there, but I just didn't look. More questions? Okay. So the rest of my talk is about my personal lessons learned and like how it all played out for me. And it has a lot to do with this graph, which is the number of people on the Kotlin team. So we started as 2 people, myself and Max Shafirov, working on the design back in 2010. And then there was like a couple more. And by 2020, we had 100 people on the team, including about 70 developers. So it was a lot of people to manage. And I never thought about myself as a manager. I never learned management. I didn't know I had to. And I realized I had to about here, which was very late. So basically, of course, here you don't need any management. Here you can get by, because like if you have 15 people, like you will be much happier if you do it properly, but you can micromanage 15 people and like everything will work. And when you get to here, like if you can run very fast, you can still micromanage 35 people, which I did. But A, you will not have time for anything else. B, you will be a very unhappy person. Because, well, also, a lot of these people won't be very happy, but at least they got to write some fun code, and I didn't. So by this, well, yeah, by the end of 2016, by 2017 for sure, I wasn't writing any code. So what I was doing here was design meetings. So we were doing design on a whiteboard and like design write-ups and everything. And management was a lot of, on all levels. Like I was doing some product management, some people management, some, well, little, but some project management as well. And it was like, it was getting clear there was something was very wrong here, but I didn't know what, because I never paid any attention to how management is supposed to be done. So basically, yeah, so by the time Google announced Kotlin for Android, I was like very deeply unhappy. I was nearing burnout, and I didn't feel like it was bringing me any joy at all. And so basically I started thinking about how I can pull out of this position sometime around summer 2018. It was already like pretty bad. I hated my job, basically, although the project was great and like there was a lot of technical challenges and all that, but I like thoroughly hated my job. And I guess the only reason why I didn't quit on the spot here was just the responsibility I felt for the project. Like, I felt like I had to see Kotlin through, make sure that there will be somebody who can take over after me. So, I don't recommend this approach to anybody. Also, somewhere in here, also started another company in parallel, which isn't a great idea. You think about it. Again, don't recommend doing two big projects at the same time. It was sort of, in terms of fulfillment, it was helping a little bit because this job I already hated, and that one I didn't. But in terms of workload, it wasn't a good idea. Don't do this. Yeah, so basically what happened throughout this time was, so here I found myself in a position where I definitely had to change things, but I had no spare time to work on any changes. Like, everything only worked if I was running very quickly between people, and you don't get any spare time. We sort of tried different approaches to this and like to try to hire somebody who knows how to manage people, and that didn't work out because like an external person didn't really work well with the team. So we tried to restructure the team, and that helped a little bit. So there was a gradual process. Where we ended up here was basically we had so we call it headquarters. Like, we had a team of 4 people, and we were making all the major decisions by consensus. It was a huge relief because I had 3 other people who cared about the same things as I did. Because by here, I was absolutely alone in thinking about big things in the project. Because everybody's writing code and having fun. And I was like caring about whether competitors will outpace us or other things like that. So yeah, by 2020, we assembled this headquarters where people cared about the same things. And it started getting more or less clear that I could like just step away and everything will keep working because there's this group that will make the same kind of decisions and we are on the same page and all that. And this is what I did. So basically I just stepped aside and everything worked. Yeah, so it took me some 2 years to figure out how to properly step aside without crashing the whole structure.
Can I ask a quick question?
Yeah, go ahead.
So I think a few slides ago, you mentioned that JetBrains was about 300 people.
Back in 2010, yeah.
So did this, what percentage of the company was devoted to Kotlin in these stages then?
Yeah, so I don't remember the exact graph for the company, but in 2020, I think it was about 1,500 people already in the company. So it was a small percentage, like, what is it, 7%? Not good at this kind of arithmetic. But yeah, so it was, the company has become much bigger. And we were like, in terms of people, by far not the biggest department. Yeah, so IntelliJ IDEA, I think, today has over 600 people. Yeah, and there are many more projects like that.
And we've talked about kind of the fact that the Java release cadence and the features that they're adding and things like that. Does the Kotlin team feed back to the kind of Java ecosystem with the JEPs or anything like that?
Yeah, that's not directly. The actual process for JEPs is not very open. Like, external people don't really submit JEPs. I mean, there probably is a handful from like IBM, but that's it. Like, but I think Kotlin, as like just by existing, did influence both Java and C# and other languages, because first of all, I think, I have no hard proof, but I think the Java team got a little more relaxed about introducing experimental features after we did that a lot. So we basically pioneered this thing in the programming language space, where you can say, okay, so we're trying out this design. It's like heavily sprayed with warnings all around. So you'll be you're sure to know that you're using something experimental if you are. And we will take it back and we'll break everything because this is an experimental feature, but you can try it out and give us feedback. And that feedback is very important. So we were pretty successful with that. I think Java sort of picked it up and looks like they're using it very successfully. So that definitely, well, not definitely, but probably affected Java. Also, things like records are quite clearly influenced by the success of this idea that was initially introduced in Scala. We use it in Kotlin, and then C# also adopted it, and Java also adopted it in the end. And there are some other things like this, like C# introduced nullable types, for example, and there is a number of other things. So basically, there is this kind of, like when we designed Kotlin, we learned from a lot of other languages, like at least 7 other languages made a huge impact on, like, their design ideas were heavily used to design Kotlin. And I'm very happy to see that Kotlin is sort of giving back by other languages using things that we tried out and that works in our language. Yeah, more questions.
You said from 2018 to 2020, was there any point there that you were doing any coding, or was it just literally just doing the whole back end and the whole
so
focus?
in terms of coding, I stopped writing production code sometime around 2016, maybe early 2017. So by that time, it was basically, the problem was I wasn't at all reliable in terms of how much time I could dedicate to a task. So anything I would take on would go forever. Like I could work on a simple thing for half a year because I was always distracted with a lot of management stuff. So I just gave up doing any code sometime around here. And what I did mostly was, like, I did like very small pull requests once in a while, especially if there was some annoying thing that was a problem for my presentation or something like that. But mostly I wasn't writing any code. I was doing a lot of design work on a whiteboard. So I work best by talking to people, which may be annoying to some. This is how I operate. So to work on the language design, we had in-person meetings where we would draft design ideas on a whiteboard and then specify those. So I did some specification. I did a lot of leading those meetings. And yeah, and all the rest was all kinds of management, like from strategy down to people management, hiring and everything. More questions? Good.
Where did your inspiration for some of the features that you're improving on Java come from? I know you said that you had an engineering team that were very competent. So did a lot of that come back from the feedback from them, or?
Yeah, so I guess most things, like most issues we were trying to address, came initially from inside JetBrains. So there were people who were writing Java for a long time. I mean, I myself had my frustrations with Java itself, but there was also a lot of feedback from people from within JetBrains. We were also talking to all kinds of people at conferences and everywhere about like what their pains are, what's like what are the biggest issues, and so on and so forth. One very important piece of advice we got initially from Roman Yelizarov, who recently resigned from Kotlin, before he joined, like 5 years before he joined. Max invited him to an internal presentation. I think it was like the second internal presentation of the draft of Kotlin design inside JetBrains. And Roman was there and told us that from his enterprise experience, number one issue was null pointer exceptions. And this is why we had nullable types in Kotlin. So, this kind of things, like hearing from people what their big pains are, helped a lot in terms of identifying issues. But then, like, the solutions to those, there were a lot of different ways. Like, I did look at other languages directly. Like, I was looking for every problem, I was looking how it's approached in different languages. We were talking to other people, of course. Like, we always had a few people in every design meeting. There was at least like 3-4 people. And happily, we had people who mostly worked on IDs for different languages. So we have people working on a C# ID, people working on Python ID, and so on and so forth. So it was very convenient to be able to like use knowledge from like practical knowledge from different sides of the industry. We also like there were like people who made a lot of impact in terms of structuring things. For example, we had like JetBrains has this legendary figure, a person who I think he started as a QA engineer for ReSharper, for C# ID, and he's like a genius QA. He can find problems with anything. Like he found like huge problems in this stock C# compiler, not only in the JetBrains implementation. And he worked with us for a while on the design for Kotlin in this capacity of like trying to break down our design ideas, and did a great job. I'm like very happy he was with us. He then moved on, works I think for Coverity now or something like that. Yeah, so there were a lot of influences from different sides. Yeah, but problems mostly came from users, and solutions mostly came from analyzing other languages and just trying to stitch things together.
Given that you were so closely, or you were steering the project for so long and deeply invested in it, when you left, or since you've left, have you been happy with the trajectory of the language?
Yeah, so one thing about inertia is that the trajectory didn't change very much, because basically the project is big, doesn't change its trajectory very easily. Also, a programming language is specifically inert system because you have to maintain backwards compatibility. And therefore, you basically can't really make a U-turn on much. Like, if you do major changes, you'll break so much code that's virtually impossible. And also, we were pretty well aligned with Roman and other people who are in charge. So, I didn't expect much change. I think that there were very important changes within the team. Like, things improved quite a bit. Because there was like the team is big and there was a lot of restructuring due. So that went well. In terms of design, I mean, things are mostly focused on the new compiler at the moment. And that's not even language design per se. Like there are some things that overlap there, but it's mostly implementation. And that's done by very good people who have been doing this since, I think, 2019 or something. So, again, there's a lot of continuity there. And my understanding is that we more or less, at the moment, we have, Kotlin has a backlog of maybe like 3 years worth of implementation. So I don't anticipate a lot of big trajectory changes in the next couple of years. More questions? Okay. So yeah, from this very bumpy ride, for me personally, as a manager mostly, I have learned a few things, which I'm trying to sort of pass on and help others not make the same mistakes as hard, at least. So one thing I didn't have and I could really use was a mentor who would actually tell me that, you're a bright guy, but you have no idea how to manage people, and we will help you, and just to learn how to do it, and maybe just not to do it all yourself, so on and so forth. And yeah, I really wish somebody told me that, because I was like incredibly overconfident back then, and like this kind of sobering advice could really help. Also, we were like super hesitant, and in the very beginning, we were very hesitant to sort of to invite people over to the Kotlin team from other teams at JetBrains, because Kotlin was this kind of crazy moonshot experimental project, and we were kind of shy to distract people from projects that actually made money. That was a big mistake. We should have set up a strong team, both from people from within JetBrains and with compiler people from outside JetBrains. It would have gone much better in all respects. So first of all, having more senior people on the team, I would probably get this kind of feedback maybe in a much harsher way, but much earlier. And also like the whole like implementation thing and performance and everything would have been much better. Also, this is what happened in the end, but I was very slow at picking this up, was investing into growing people into managers. Because it turns out the bigger the team, the higher like the higher the demand for managers, and the bigger the pain of not having enough good managers, especially if your team is a bunch of very bright engineers who don't like bullshit and don't want unqualified people managing them. So you have to be like a good developer and have some skills and inclination towards management. So I should have done this much earlier than I started. So that's a big lesson as well. And also, yeah, as I said already, like release 1.0 much earlier would have done us a lot of good. Any questions about this?
So you're talking about hiring seasoned experts from the start. So that's made me think of what was the kind of funding or requirements from JetBrains for the project? Because and often in startups you might not have the money to do that. But I guess this was. What did they need to see from you to keep the project going?
That's a very good question. So the thing about JetBrains was and still is that it's a massively profitable company with a lot of resources, and also some sort of like not much liking towards like structuring finances. So like at some point I was asking like, what's my budget for the Kotlin team? People are like, okay, do you need something? Yeah, so it was. We definitely could hire senior developers at that stage. I mean, there probably would be some sort of conversations about like how much we can pay and so on and so forth, but we had money, definitely. So it was more of a psychological thing. Like I didn't know how to do it. Other people thought I was supposed to do it. It was kind of nobody's area of responsibility, like nobody's realized their area of responsibility or something like that. Yeah. More questions? Okay. Yeah, so a quick summary of what you need to do to make a language. And that's quite a few things. So one thing is language design. Like you need to create some kind of abstract idea of how the language works. And that has a lot of details. Like this whole list, you have to figure out everything and how it works together. Because you can come up with a great module system, for example, that will have nothing to do with the rest of it. And, it's not going to work. Then working on the implementation, a compiler is a very, very complicated program, especially if you have a lot of constraints like memory and performance and also compatibility with other things. But then there is, like on top of that, there will be an IDE, there will be a build system, and there will be need for incremental compilation, for example. And just to give you an example, incremental compilation is a hell of a problem, especially if you're running a compatibility thing, like interoperability thing with Java, because if you think about it, so you have a mixed project, Java and Kotlin. So you have two compilers. And when you compile Java, the Java compiler doesn't know that Kotlin exists, but it has to reference symbols in the Kotlin code. So the way it's compiled, you first compile Kotlin because it knows that Java exists. And it can look into the Java code and find symbols there. Then Kotlin produces class files, and then Java compiles its sources against those class files that Kotlin produces. So that's all right, but now you have incremental compilation. So you have a project that has been compiled, and then a few files were changed, and maybe it's Java files, maybe it's Kotlin files. And now you have some circular dependency. So some Kotlin is referenced in Java, maybe this same Java file is referenced in Kotlin. And to incrementally compile that, you need to figure out the dirty files and everything that depends on those dirty files and recompile that. And there is no exact algorithm to do that. So you have to approximate that. And what we usually do is we start with dirty files. We look and like we have some sort of a log from a previous compilation that knows what those files depend on and what files depend on them. So we take the files that depend on those dirty files, we recompile all that, and look at the delta, like how did the symbols change? And if it's a significant change, like the change that affects some other files, we add to the set and recompile everything again. And it can go in iterations, like many iterations. Usually it's few, and this is why it's faster. But in principle, it can be like super slow because you have to recompile other things all the time. Yeah, so and that's like a super complicated algorithm. So no other algorithm in the compiler is as complicated as incremental compilation. And that's not even on the list for most language developers. Like most people don't realize they need incremental compilation at all. So, and then a lot of other things like libraries. Libraries include both like basic wrappers for collections and coroutines that are hugely complicated algorithms of like parallel execution and everything. So implementation is a big deal. Also, like debugging. Debugging is a surprisingly complicated thing even though you have great support from the JVM. So the JVM supports debuggers very well. You can inspect stack frames. You can like trace bytecode and everything. That's wonderful. But now you have Kotlin, and the debugger interface for the JVM is kind of designed for Java. Kotlin's not exactly Java. The classes don't match one-to-one. Sometimes there is a number of Kotlin classes for one source file, many more than Java is used to. And also Kotlin has inlining, like I have inline functions, and we have to debug through that. And if you've been with Kotlin for a long time, you know that it wasn't always a smooth ride. Like early versions of Kotlin, debugging for inline functions didn't work well because it's hard to get right. And a lot of other things. So like things like a decompiler. You need a decompiler to properly debug binary code. This is how you get anything comprehensible for the user. So that's a tough enough problem on the technical side, but also how to manage the product. You have to prioritize what you do today, what you do tomorrow, what you never do, what bugs you fix, what bugs you don't fix, what bugs you fix and break compatibility, because the impact of a breaking change will be less than an impact of not fixing the bug at all. So there's like a lot of product management stuff. And then, of course, you have to work in the team, and you have to work with partners because you work with, like, you integrate with Google, Gradle, and many other things also are in the picture. And you manage the community. So everything apart from managing the community, I was doing at the same time. It was a very bad idea. Yeah. I mean, I did learn a lot. I even learned a little bit about management, and much more than I expected to learn. Yeah, but it was still like a very diverse set of things, and also very interesting, but incredibly distracting, because you have to switch between all these things, maybe every day, and like anything that doesn't fit into a slot on the calendar just doesn't get done. So it's a very sort of, as a developer, I was used to this dopamine cycle where you write code until it works, and when it works, you're very happy and you want to write more code. Doesn't happen in this structure at all, because like you're in a meeting and maybe something very interesting is happening, but your time is up and you're due to the next meeting. That's it. Yeah, it took me a while to adjust to this. Any questions?
During the whole designing of the language to the implementation, how long did it take really, time-wise?
So basically we stabilized the design and the implementation enough to commit to it in 6 years, in 5.5 years. So we started in 2010 and released 1.0 in early 2016. So that is to say that design doesn't really end because it's an ongoing process. So basically, in the design stage, like pre 1.0, we generated a lot of design decisions, some of which weren't implemented. And we spent basically the entire 2015 of course, chasing bugs, but also fencing off future changes. So our job was to finalize design decisions and put in checks so that we definitely reject the code that we want to change in the future. So think of it this way. Let me try to think of a feature. Like, okay, I don't have a good example, but this one will work. So there are a lot of intricate, annoying rules around inheritance. Like what kind of things you allow to be overridden, in which circumstances, so on and so forth. And like you can think of very interesting algorithms, especially with generics that make everybody's lives much better, but you don't have time to implement them. So you want to make sure that those things that you want to handle in the future are just not possible today at all, so that you don't introduce breaking changes. If somebody tries to write this code now, it doesn't compile, it's red code, which means that next version, it will be a new feature. You just make some red code green. Hooray. If you make some green code work differently, that's very bad. Like you're definitely breaking somebody's code in a very subtle way. It still compiles, but it works differently. This is very bad. Like you have to, like we definitely sided on the side of let's reject more code, but be sure that we don't change behavior without the user knowing.
Okay.
Yeah, and that was like an entire year was mostly focused on that. And like finding inconsistencies and other things like that. Yeah, so one of the examples would actually be, we would, like for suspend functions, for example, we had to reserve the keyword suspend up front, not to disrupt any syntax later. So we were like specifically, and it's a soft keyword, so you can have things called suspend. In the language, you just are not allowed to use them in a specific way. So we made, like introduced an error, like a compilation error that says, if you say suspend curly brace, that's not allowed before we actually release coroutines. And things like that, a lot of them happen. Yeah, more questions? There's a mic behind you.
How many hours per week you worked on Kotlin?
More than healthy. I think by the time I gave up my PhD and worked full time, it was something between 50 and 60 hours a week. Yeah, and later on, like when I already wasn't in very good shape, I would go back to 40 and like be very strict about that, but it already was too late. More questions? Okay. Yeah, so two biggest challenges for me in terms of management and all that was the opposition between narrow focus and broad appeal. So we really, well, it's my personal sort of bias. I really wanted to cover a lot of ground, a lot of breadth in terms of like doing a lot of platforms from server side to client, including WASM and native and all that. I really wanted all that to be done in parallel, which is, I mean, sounds very interesting. There is always something to tell about, like to give talks about in the next conference and all that, but it also grows the team, complicates the management process quite a bit, complicates the technical implementation because all this has to talk to each other. That's like the integration of the native toolchain into the Kotlin project was a huge pain in terms of infrastructure and everything. Like it took us a long time and introduced a lot of hurdles. Also like all of libraries because users need libraries and this is blocking everybody. also different IDs, because it's like every IDE has its own audience, and this is how we reach users. It's all very appealing, but it has a huge cost on the management side. And you're always short of developers. You don't have enough hands to do things. And then if you have enough hands to actually program, you don't have enough managers to work with them, So it was like a very big challenge for me. Another, I already mentioned this, that managers may be more precious than good engineers, even because there are much fewer. Also, yeah, lessons learned. Any questions here?
So you're saying top engineers rarely make good managers. Like, in your opinion, what most top engineers don't get when they become managers? What are the typical mistakes?
Well, I would probably rephrase that as you need to be a decent engineer to manage good engineers and like get their respect in an organization like JetBrains. It can be different in different organizations, but in an engineering-centric organization, you have to be a decent developer to be a respected manager. So in terms of the mistakes people make, it's I will do some management and I will still be as productive as I was as a developer. Very unhealthy decision. Like, some people manage to keep up with both, and it's not good long-term in terms of like, neither a dead manager or a dead developer does any good to the company. So this is what I tell everybody who's trying to overwork themselves. So that's one thing. Another thing is there's a very big trap, the switch from a very quick feedback loop with your code, where you wrote it, it works, you're happy, to, okay, you are hiring this person. You've put in quite some work, interviewing and everything, and they will show up at work in a month. Have no reward today. And like, if they will help you, they will help you after they onboard 2 months later. So that's a completely different reward cycle. It's very difficult to adjust to if you're very used to something just running overnight at worst. So that's another big thing. There's also this idea of like, how to put it? There's also this idea of areas of responsibility and things like how much impact can a single person make? And also this sort of bias towards very visible results. The results of management work can be hard to see because there is no commit message, there is no test passing, there is no functionality in the product. So the biggest skill, I think, for somebody who was a developer and becomes a manager is to find some pride and satisfaction in their results as a manager. Like, it's something you have to learn to be happy and to be actually like productive and motivated as a manager. So these are the things I try to teach my mentees, and so when I do coaching, I try to help with this, because otherwise you burn out, like, very surely. Most people do. Yeah, I think these will be the biggest follow-up questions to this.
So would you say it's better for managers to maybe step aside from coding as much, just so then they can focus on the whole team and the whole broader project, really? Or do you think they can still kind of lend in and maybe do pull requests and features and that?
Very good question. I think it depends on a number of factors. So first, if you have a small team, a lot of people manage to do some coding. You just shouldn't try to do as much coding as you did before you managed people. So like the way I usually try to set it up for newly starting managers is, okay, now you have a full-time job in management. How much of that are you giving up for coding? Not the other way around. Yeah, so in a small team, it's definitely doable, but you need to have a very clear idea of like how much time you dedicate to what. And especially, well, the most important bit of this is to set the right expectations of yourself. Like how much code you are supposed to get done in this week. And like if you're doing, I don't know, 30 hours of management, you should be able to do at most 10 hours worth of code and not another 40 hours. Yeah, so that's one thing. Another thing, like if you're running a big team with like a lot of sub teams, you have a lot of direct reports or like a lot of concerns to address. It's unlikely you'll be able to complete tasks in time unless you're very good with your like. You can manage your workload as a manager to carve out some time for coding, but you have to be a skilled manager to do that. So, it's not something you should expect to be easy. It's something that will probably not work from the first try. No, you'll have to work on this kind of balancing your calendar and everything. So that's another thing. And also, like I've seen people at very high positions who do occasional coding. The big question is why they do it at all, because there is this huge bias where a team lead would do the things that nobody wants to do because somebody has to, and I don't have any feature I'm working on, right? So I'll be fixing tests or I'll be doing infrastructure and so on and so forth. And sometimes it's frustrating work, and this also causes burnout. So you need to be sort of conscious of what kind of code you do and why. Like if you do it to feel you're still on top of your game, you're still an engineer, you don't have to torture yourself over this. Like you can take something more pleasing, like more fulfilling. And again, like you have to think about it, because like in general, when we talk about who does what in a team, there shouldn't be a punished person who does all the like scut work. No. That's a very bad. This person will probably be the unhappiest person in the team, and if it's the manager, that's a very bad solution. More questions?
I wanted to ask. So when you were working within the smaller team, did you feel that you needed to have a manager? Because I'd assume everyone else was more or less on the same page. Like when it was small as the team.
Yeah. So in a team of like 5 people, you don't need a formal manager.
Yeah.
It doesn't matter. I mean, especially if you don't have to like update salaries a lot or allocate bonuses or anything. Yeah, you don't need a manager.
At what point when you was with JetBrains and doing this whole Kotlin, did you feel that, we probably need a manager as we're getting more and more larger with more and more sub-teams and such?
So in our particular case, we actually made a lot of use out of, like we were hiring fresh graduates from university. We had good relationships with very good universities, and we just managed to attract like really bright people very early on, which is a great strategy if you can afford it, because these people don't leave the company. They grew up here, they like this company, they will stay. And as soon as you have a lot of junior people on a team, you definitely need managers, because these people need attention. That's one thing. Also, when you grow to maybe 8 or 10 people, it's probably going to be enough sort of oversight required to merit a management role. At least a part-time management role will be absolutely necessary.
Yeah, I was wondering, wow, it's really loud. I was wondering, like programming can be very fiddly. And of all the things, what was the most fiddly thing you had to deal with?
Fiddly. Ooh.
Or complex is another one.
Yeah, so I think in terms of, so if we take this picture here, sorry. So out of these things, I don't, do I have interop here? So, okay, so from language design and implementation, the single biggest sort of cross-cutting concern that we had in terms of complexity was Java interop. Because Java interop touches everything. It's in the type system and abstractions, in these things like safety and runtime semantics and traceability and module system, everything here is affected, but also it's in the compiler, it's in the binary format, it's in every library, of course, it's in the build system, it's in package management and the IDE and the debugger. in also I mentioned incremental compilation is a huge part of actually build system and the IDE as well. It's yeah, so all these things are affected by your decisions in interoperability, and like implementation everywhere has to account for it, and the design of the language as well. So in that sense, this is the biggest, like the most complicated cross-cutting concern. In terms of subsystems, I would think the most annoying part was either the build system or the debugger, because it's a lot of subtle bugs that they're hard to isolate. There's a lot of moving parts, a lot of sort of variation of circumstances. So these are incredibly annoying. Also, especially performance in the build system, very hard to do. And like Gradle is not a great platform to build on. It wasn't built for initially. I mean, this initial design was not for like extension or this kind of scale that it's used on at the moment. So in terms of pure language design, I think it's still, yeah, so still the things around interoperability, like we have those fairly exotic things like platform types, flexible types. They're really complicated in terms of algorithms. So it's within the type system, but it's this part that is most difficult.
And to add to that, was there anything that was particularly engaging and rewarding to work on?
The parser was great. No, but really, it's a lot of things that have a clear like beginning and ending were very rewarding, because the annoying thing about interoperability was we only could get it right from the third try, and a try is you implement everything, you start writing code with it, you show it to the users, and they say it's shit. So, you know, it was like we initially tried to get away with something very basic in terms of interoperability of nullable types. Like the biggest impedance mismatch between Java and Kotlin is Kotlin has nullability and Java doesn't. So we started with, okay, everything in Java is nullable. And so every library we're using from Java will just have a lot of nullable types. And we have those nice operators like safe calls and everything will be fine, right? No, will not be fine. And we didn't realize it before we implemented everything and started writing code. And we're trying to get away with things like annotating Java types with nullability annotations and all that. And by the way, type annotations in Java don't really work that well. Not because the design is bad, but because nobody really used the implementations ever. And in the Java compiler version, I don't remember, maybe 10.9 definitely, there were so many bugs around the type annotations, a lot of bugs, because it's not a feature a lot of people use. And, you know, bugs are there. Nobody fixed them. Nobody found them. So, you know, that didn't work. And we went with other things, like we tried a couple of iterations of other compatibility mechanisms. And we like invited a type system specialist to help us with intricate designs there. He made a proposal. We took the proposal, we completely redid the proposal because like this very nice piece of mathematics that he produced was not possible to do well in practice, and we had to redo everything. So you know, it was like a few iterations, and it took like 3 years in total. So yeah, it was a pretty hairy kind of task. Yeah, more questions? Oh, 5 minutes. All right. Okay. So we talked about this. Yeah. So basically, yeah, my learning curve was I started as a overconfident 26-year-old who thought that he knew everything, and then, you know, got to micromanaging 30 people, learned the hard way that you can't really do that, and you know, trying to juggle a lot of roles didn't help. So yeah, I was in this kind of situation by 2018, absolutely, and it was like sort of ironic that I have already started a mental health company by that time, unintentionally. Like I didn't mean the irony, but it was there. So it took me a while to recover, and like burnout was the beginning. Oh, well, was at the beginning of it, but like I had a major depression after that. In any case, so my takeaways from the management story is that leading teams is a profession. You have to learn it, like explicitly. It's not something you pick up as you go, especially in a large scale project. As I mentioned, it's important to learn to own your accomplishments and like to feel rewarded for what you're doing. It helps tremendously to diversify, like involve more people into decision making, and to also diversify your sources of joy. So my entire like primary source of joy was work, and when things went bad at work, my whole life went bad. Like there was nothing to counterbalance that. And yeah, well, the happy bit is that burnout is curable. You can work in it. It takes a while, but you can recover, and I'm pretty fine now. Yeah, any questions about this? Okay, yeah, so if you want to know more about burnout and how to fix that and depressions and all that, I have a lot of domain knowledge, so feel free to write to me or talk to me. I'll try to help. Yeah, so this is a slide I should have removed. Sorry. Yeah, so thank you very much for your attention. So basically, the bottom line of this talk is it's all very nice and funny when you look back on it. Again, I may misremember things. And I'm happy to share my knowledge in general. So if you or anybody you know works on programming languages, we can talk. And yeah, I like helping tech leads not make the same mistakes that I have. So yeah, if you have questions, you're welcome. Thank you very much. We may have another minute for final questions.
What advice or tips would you give to any Kotlin developers using the language on a daily basis?
Have fun. Well, I don't think there is any kind of blanket advice that would work for everybody. In general, it always helps to sort of have a growth plan for yourself, like to learn new things or improve your skills, just not to sort of be static in your professional persona. That's about the only thing that sort of works for everybody. Also, yeah, don't overwork yourself. It usually works for everybody. Nothing else so generic, but if you have more specific questions, I can probably specify something.
You just mentioned obviously hindsight, and I know there's probably lots of little different things you would change, but is there one, having gone through it all and all the alterations you had to make, is there one main thing that you would have done differently?
Main thing? Well, it's hard. I mean, I would have definitely done the whole management side differently. Is there one thing that could have changed everything? Probably having a mentor in the very beginning could have helped, like turn everything around. No, like change how everything went. Probably that, yeah.
Sorry, me again.
Yeah.
Going back right to the beginning stages when JetBrains had this idea of creating a new language, I know that you said throughout the process you did kind of copy 6 or 7 other languages, but right at that initial stage, did it ever kind of come into conversation about reaching out to another programmer that actually had gone through the same journey and created their own language from scratch to kind of learn and absorb from, to see how they did it?
No, and yeah, but it's a very good question, and it's sort of characteristic of myself and other people in the team. But it's just not what we do in general. But probably, well, knowing the people, because over the years, we obviously talked to people working on other languages. Like we have pretty good contact with people working in Java, people working on Scala, some people working on Groovy. So it would have probably helped. Well, I mean, they wouldn't have been able to help very much because they're direct competitors. So it's not like you can invite someone to like consult on such a project from a competing language. So not like that, but actually the way it went, I integrated pretty well into language developer community, because the Java people run this very small, very specialized conference every year, which is called JVM Language Summit, which is where we announce Kotlin. And we went every year, and we did have lots of conversations about how languages evolve. And specifically, I sat on a committee for Java language evolution. So I was sort of not very intensely, but a little bit involved with designing Java 8 and a little bit of feedback on Java 9 and so on and so forth. So it wasn't like I was completely disconnected from this world, but I didn't have, again, like a mentor or anybody else I like directly tried to learn from personally. Yeah, that never crossed my mind, you know. It's something I'll probably learn one day, that like having a proper mentor from the start actually helps a lot. Yeah, good point. More questions?
Do you have a mentor now, or do you have someone that you would?
Another
Is there a
good point.
person in your mind that you think you would want as a mentor in the industry?
Yeah, so this is one of the things. So one thing I learned is how to use peers, not mentors, but like I have a group of people who are now friends, and we exchange this kind of, not even advice, but like requests for like, ask me questions about this. I'm going to do this big thing. Ask me questions to clarify whether I actually thought enough of this, and like if I'm missing something, or so on and so forth. So that works very well. And I have a number of people I regularly have such conversations with. So that's more of a like personal board of directors kind of thing than a mentor. I think I'm going, like, in my next big project, which hasn't started yet and has to do with like simulating social processes, like updating the tool set for economics and social science. In that project, I hope to have a mentor, somebody who knows much more about the academic world than I do, and so on and so forth. But I don't know the person yet. Yeah, so I'm learning, but I'm not there yet.
Do you think you would want a mentor outside of the expertise you're working in? Like, for example, you said you needed someone more in the management side of things.
Yeah, so if I do much management again, I will definitely use a lot of external expertise. I've already used quite a bit of it in my current company. So especially when we had to hire people, I know nothing about their jobs, like marketing director, for example, or CEO. We all have all hired management team at the moment. So we did reach out for external expertise, and that worked very well. So yeah, again, not fully utilizing the potential of mentorship there, but I'm getting there. More questions? Are we out of time? Okay, right. Thank you very much.